these laws of motions from Newton, okay? And we solve some problem to practice this, okay? For such kind of problems, you have to follow 3 steps, okay? I hope you still remember. The first one is you have to, wait a little bit. I remind a little bit about last time, okay? Paint. Need to change to pen mode. Okay. True color. Okay. So last time you learned about what is the force and 3 law motions from Newton, okay? And to solve such kind of problem related to this, you have to follow 3 steps. The first one is you have to write down, draw, okay, or graph or sketch the free body, okay, diagram, okay, which show all forces acting on each subject in the system, okay? And the second one, very important step, is you have to define the x or y coordinate, okay? Very important, okay? Why? Because when I look at the solution you send me, I see that, okay, you have an object, you have many force acting on it, okay? So on, okay? And then you didn't define the coordinate, okay? What is the x, y directions and so on? And you just write, okay, for example, t minus mg, blah, 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 okay? Oh, but how you can know t is positive and mg is negative if you didn't define the x or y directions, okay? And the second step is very important and you have to do it, okay? And the next step is you can apply some normally the second law from Newton's, okay? And you project the functions on our x, or y, and so on, okay? And you find out some equation and then you can find out what you want. Okay, this is the knowledge from the previous lectures. Okay, and today what we'll learn, in fact, you learn it from Miss Wen, and my job is I just reviews all of this for you. Okay, and in the chapter 2, okay, the rest of the chapter 2, you have to learn about everyday forces. Okay, and in this part, there are 3 kinds of forces you have to understand, okay? In fact, we have only 4 fundamentals kinds of force, okay? You have here just extra information for all of you, okay? You have what? You have strong force, okay? You have electromagnetics or magnetism force, okay? You have gravitational force, okay? And the last one is weak force, okay? We only have 4 kinds of forces like this, okay? But in B1, the way we call it a little bit different, but the origins is just one of them. Okay, so let's see. The first one is gravitational force. Okay. You have this kind of force when your body have mass. Okay, and you see that we are living on the earth. Okay, we are living on the earth. And on the earth, we have human, you have a house, you have a bone, you have a table, you have a rulers, okay? You have many things on the surface of the earth. But keep in mind that only the Earth have the big mass. Okay, you see here is the value of the mass of the Earth. Okay, and all the other things have very small value of mass. Okay, so that's why we just care about the force acting on all the other thing due to the Earth. Okay, so for example, you have the mass m1, you have the mass m2. Okay, when you have a mass like this, the environments around its body have a field. Okay, and it's called gravitational field. It's like electric field or magnetic field. Okay, it's a field, and when you put another object into that field, there will be interactions between them. Okay, and I think that you may be so familiar with the electric field. So G here is a field. It's similar to the E field, electric field. Okay, but the field here is due to the field here is around the body, which has a mass. Okay, and because as I explained, the Earth is the only thing which have the huge amount of mass. Okay, so here is the Earth. Okay, and here is the mass. The mass here is maybe you, me, or maybe it's a table. Okay, and this mass, okay, have the field G is always pointing to the mass. Okay, you see the arrow here. Okay, and here is a G field of the Earth. Okay, and this mass have G field too, and it's pointing to the mass too. G, I call it G prime. Okay, and when you look at this, you will see that the G field of the Earth equal this is a constant. Okay, and here is the distance from the center of the mass to the point you are consider. For example, I consider the G field at this point. Okay, due to the Earth. So R will be from the center of the Earth to the point you are considering. Okay, and because the mass of the Earth is so huge, okay, is huge. So G of the Earth, when you calculate, when you put everything, you replace the value of G, M, and R, and blah blah. Okay, you will get the value of the Earth. G is around 9.8. Okay, and if you calculate the G prime of another object, of any object, you will see that's because the mass of that object is so small. So the G field here, G prime of any other object is so small compared to G. Okay, so normally we ignore it. You understand it? We ignore it when we compare to the G's of the Earth. Okay, so normally we just care about gravitational force due to the Earth. Okay, here is the Earth. And when you have another object here, another object, I call it M. Okay, and because the G field due to the Earth is always pointing to the Earth like this. Okay, call it G. It's a vector, and it's equal to this. Okay, note it down because I didn't see this function in the slide of Miss Vân. Okay, and when you put another body, another object into this field, there will be the force acting on this body due to this G field. Okay, and this force acting on this will be equal mass of the object multiplied by G field. Okay, when you look at this, we see that, okay, M is positive. So F and G have the same direction. So that's why F here always point to the center of the Earth. Okay. So if you replay G into the function, you will have F will equal minus G M, big M multiplied by R over G squared, R squared. Wait a minute. I don't know why it's okay. Here is just extra information for someone who would like to know deeper about this such kind of force. Okay, and I know that many of you just, I don't know, don't really care about it too much. Okay, so you just need to remember that when you will have a mass, okay, and it's near the Earth, there will be a gravitational force acting on it, and the directions of the force is always pointing to the center of the Earth. Okay, that's all. And here is the function to determine the directions and the magnitude of that force. Okay, G constant. In fact, when you look at this, you see that G is not a constant. Why? Because the big G is constant, the mass is constant, but the distance here is between the center of the Earth and the center of your mass of your body. Okay, but if you change the positions of the body, not here but here, you will change the value of R. But normally the distance from the surface of the Earth to the mass so small compared to the radius of the Earth. Okay, so normally the value of G is I think it doesn't change too much. Okay, so you can take the value 9.8. Okay, even if you change the position of the body, maybe 100 meter to 1 kilometer far from the surface, it doesn't change too much the value of the G. Okay, and the second kind of the force you need to know is the friction force. Okay, this force is due to the microscopic interactions between two surfaces. Okay, in fact, it is electromagnetic force. Okay, in fact, it's the electromagnetic force due to the electromagnetic interactions between the surface of the atom of this surface and atom of another surface. Okay, and we just care about friction force when you have the relative motions between two objects. Okay, you just care about the frictions, okay, when you have the relative motions between two objects. So two objects here can be between solid and solid, can between solid and fluid, and can between fluid and fluid. Okay, when you have the interactions between fluid and solid, you have a drag forces. Okay, and when you have the interaction between this fluid and another fluid like water and oil, for example, okay, you will care, you will call it the viscosities. Okay, but in B1, you just care about the relative motions between solid and solid. Okay, and the interactions between them we call it the surface frictions. Okay, surface frictions. For example, you have a block and you put it in a table like this, okay? And when you care about the interactions between solid and solid, okay, and you look at the relative motions, and if the relative motions between two objects here is zero, it means when you have a block and you put it on the table and you act on it a force like this, but it doesn't move. It doesn't move. It means the relative motions is zero, and it's where you care about static motion. Static frictions. Okay, we call it the static frictions. Even you acting a force on it, but it doesn't move. It means the relative motion is zero, and is where you care about static frictions. Okay, and because due to the first law of Newton said that if an object doesn't move, it means the next force acting on it will be zero, right? So here you acting a force on it and it doesn't move. Okay, what does this mean? It means must be there another force acting on the block, and it should be opposite to the force you acting on it, right? So here is the static frictions, okay, and opposite to the force you're acting on the block. You understand it? Okay, and this static frictions will be equal mu s, okay, coefficients of static frictions multiplied by normal force. Okay, you learn it from Newton, it's good. Okay, and when you increase amount of force acting on the block, it's move. Okay, it's move. It means the relative motions between two objects is not zero anymore, and it's where you have the kinetic frictions. Okay, okay, now it's move. Here is block, here is a table. Okay, and you increase the force acting on it, you see it's higher, larger than the force before. Okay, and you see it's move this one. Okay, and we have also the friction here, and in this case when it's moved you have to care about kinetic friction. Okay, and because frictions it reaches to the motion of the object, so if object move in this direction, it means frictions should be opposite like this. Okay, and here is F. In this case, it should be not Fs, but Fk. Okay? It means kinetic friction. And kinetic frictions is also equal mu. But mu here is different from mu s. Okay? Here is coefficients of kinetic friction, mu k multiplied by n. Okay? And mu s is way larger than mu k. Okay, so we have two kinds of friction: static friction when the relative motions between them is zero, and kinetic frictions when the relative motions between them is not zero. Okay, and they are different. The coefficients of friction is different. Okay, that's everything you need to remember about friction. It's okay. And I see in the slide you learn the another kinds of force, okay, from the Hooke law, okay, and I don't know why in the list of problem you have no problem related to this, okay, and you will learn about it when you learn about energy and work and so on, okay. So here I just talk a little bit about it. when you have a spring here, spring, and another one end of the spring is fixed to the wall, okay? And here is the natural length of the spring, okay? Here is the natural length of the spring, and I call it is 0, and this direction is x, positive one, okay? And if I pull these springs in this direction, I act on it a force like this. For sure that your spring will be elongated like this, right? Okay, and the displacement is moved according is x. Okay, and you will see that here the force acting on is F. Okay, and the displacement is x. Okay, and what is k? K depends on the size of the spring. It can be stiff and it can be loose. Okay, if it's stiff, K will be higher than the case of the loose spring. Okay, what does this mean? It means you need the largest force to acting on the spring to move is the same displacement. Okay, so K here is just constant. Okay, and it's one of characteristics of the spring. Okay, it depends on the shape and the material you use to make the spring. Okay, and F here will be equal K multiplied by, I call it delta X. Okay, delta X, and in this case F and delta X is positive. Okay, but when you act on the springs of force F like this, the spring will try to come back to the origins, right? And here I call it F. I don't know, in the slide she call it F, but its name is restoring force. So I call it F, F restoring. I'm not sure how she call it. Do you remember how Miss Vân called this force? Sorry, let me check. She just called it F. It's okay. It's okay. So I just call it F. Okay. So I will call it F. P. Okay, is the force U acting on the spring. Okay, I call it pull. P stand for pull. Okay, FP is the force U acting on the spring. Okay, and F here is the force spool as the spring acting on you. Okay, it's okay. Or if you have an object here, is the force you acting on the object. Okay, and this force have the opposite direction to the P, the FP here. Okay, so it will be equal minus K delta X. It's okay. the minus sign here tell you that the F is on way 10 to bring the spin back to the original length, okay, original state. Okay, so that's why you have the minus here. Okay, so here is just a bit about the Hooke law. Okay, you will practice on it next lectures. Okay, so now we will jump directly into some problems to practice. And today we just focus on gravitational force and friction force. I don't know why. Okay, so here the first problems. Today we focus on problem 18, 19, 20, 21, and 22. I hope I can guide you go through all of these problems. Okay, so now I will give you maybe 1 or 2 minutes to read, and then one of you will help me to solve these problems. Any questions about such kind of and any question about this part? Any question? Any question? No? So let's start. So consider this diagram, okay? So here you have frictionless pulley. Okay, here is the pulley, here is platform. Okay, so why do they have to stay frictionless? Because in fact here we have a relative relations between pulley and the string, right? In fact, you have to care about the frictions between them, okay, but it will make our problems so complicated. Okay, so that's why here they put this word here. Okay, so you don't need to care about the frictions here. It's good, right? So performance weight total Newton, okay. Okay, so they ask you the force here. You have to act to the rope, okay, to make the to lift the platform at 3.2 meter per second square. First, free body diagram, okay. When you work on forces, you have to do it. So one of you can help me to solve this problem.
Can I try it?
Yeah, tell me your name and student code, please.
My name is Bảo.
Now,
ID is BA 11
11.
107.
Okay.
We have the gravitational force. The pulley grip is a force exerted.
Can you repeat? It's quite difficult for me to hear your voice.
Yes.
Okay. Can you repeat, please?
We have the pulley weight is like a gravitational force exerted on the platform downward.
Okay. You call it what? P?
Yes. And we have the force F is written on yes, and we have the tensions.
Okay.
Tension on the both the leftmost and the rightmost of the rod.
Okay, so here is the left and here's the right. Okay, so have the tensions because it's pulled down, the source of tension should
To downward,
upward.
upward.
Upward. Because everything is pulled down, so it's pulled up, right?
Yes.
Mm-hmm.
So we have the so apply the third law of Newton, the third law of Newton. Have the tension force is opposite to the F, the force F. So we have T is equal to F.
Another sign here, you have T as well, okay, because it's pulling.
Yeah.
So it's the same.
And we apply the second law. We have the gravitational force is upward. Sorry, it's downward, and two tensions force is upward. So we have the functions is m multiplied with a.
Okay, can you repeat?
M multiplied with a. M is the mass of the platform. Is equal to 2 multiplied with a T tension force minus B
Plus B.
plus B.
Okay.
So we put it to the OX and OY coordinates. So we have
okay, so first you have to tell me what is OX, OY and directions.
Y is upward and OX is perpendicular.
In fact, you have no force on the horizontal direction, so you don't need to define OX. Right?
Yes.
Because all forces here is vertical.
Yes.
Okay.
Yes. So it's equal to MA.
So you have to project these equations on a Y, right?
Yes. M multiplied with A is equal to 2T minus P. Yes. And I rewrite this function for according to the T is equal to MA plus P.
What?
Ý là em muốn viết lại cái phương trình MA bằng 2T trừ P theo T để bởi vì sau đấy T bằng F. Okay, it's okay. It's 2T.
Because you just explain here F equal T, right?
Yes.
So it's just to replace T by F here. So we have equal to F
minus
P. So you have to find out F, right?
Yes. F is equal to MA plus B all over 2.
2 is good, right?
Yeah.
So
we have the mass is equal to according to the second law of Newton, the mass is equal to P the gravitational force over the G acceleration.
Right?
Yes. Multiply with A plus
P
B
over 2. So you know P, you know G, you know A here, right?
Yes. So
just tell me the final results.
Is 22.55.
0.5, right?
Yes, 0.55 Newton.
Newtons. Okay, so it's what? So here in this problem, you just need to determine the gravitational force you gained point, okay, and t will be equal F here, okay. We have no friction force here, okay, so all the other thing is so easy, right? This problem is so easy. So we will move to the next one. Okay. So you, let me draw it. Okay. So you have a frozen lake like this. Okay. And you have a hopping like this. Okay. And it starts moving at speed of 12. I call it V0. Okay. In this directions. And then you okay. So they give you after 5 seconds, its speed is equal like this. Okay, at the beginning it's like this, but after 5 seconds it's like this. Okay, it reduced. Okay, decrease. And they ask you about its average acceleration. Is so easy, right? What is the coefficients of kinetic friction? Okay, here because this mass, okay, is moving, so you have to care about kinetic friction, not static frictions. Okay, between the puck and the ice. Okay, here the eye and here is the puck. Okay, and because it's more in these directions, so the frictions force will be in this direction. Okay, I call it F. Okay, okay. And they ask you about new case. Okay, and in the last part, how far does the puck travel during this? Okay, 5-second intervals. Okay, so I think this problem is so easy. Okay, so one of you can help me to do it. Yeah, tell me your name and Stephen. Repeat. Okay, so tell. Can you write down the general equations for the object first, please? The second law. Oh, wait. Very important one, you have to write out all the forces acting on the body. Okay, because Okay. When you write down like this, okay, they will understand. He know how to determine the gravitational force. Okay. Upward, not upward. And another force. You have the interactions between them. The normal force, right? Okay. So sorry. F equal what? No, the general equation for friction force. I call it friction. Okay. So a little bit. I will write it here. Frictions will be equal mu multiplied by n. Here is a general equation for friction. Okay. If it's a static friction, it should be mu s. If it's a kinetic friction, it should be mu k. Where minor. In fact, no. I'm sorry. If you write, you have no vector here. Why? Because if not, n and fs will have the same directions, right? So it's just write down the magnitude of such kind of equations, okay? And the directions is always opposite to the motions, okay? Okay, and we just write down the magnitude. The magnitude equal this, okay? And the direction is opposite like this, okay? So right here, f case will be equal mu time end. No, I not here, okay? Equal mu k p or maybe mg, okay? We just replace to this. You have mu, okay? Because here is, in fact, it deceleration, so it's be negative, okay? Okay. So the question is, we don't know how about A. You didn't calculate it part. Okay, so first you have to calculate it into A part first, and then you will solve it like this, okay? Okay, so how about A? Okay. Okay, so in this equation, because we know okay, and then you have the value of A, you put it here, okay, And then you know about GG constant, you can take 9.8, okay, and tell me the value of mu k, please. Right. 0.12 my result is 0.224. Okay, it's good. Okay, how about C part? You have S equal okay. You know T, you know should be V0, right? Okay, don't forget it. Okay, V0 in this case difference from 0, so very important. Okay, you know T, you know A, S, or maybe you can use another equations. Vt square minus V0 square equal to AS. Okay, some way for you to do it. Okay, so AS, okay, 45 meter is good. Okay, you can use which way you want. Okay, it's good. Any question about this? Okay, so in this problem, they want you to remember that the directions of the frictions is opposite to the direction of the motion. Okay, if V0 have the direction to the right, so friction should be to the left. Okay, because it resists the motions. It's the first point you need to know. Okay, it's okay. The second thing here, because it's a kinetic frictions. Okay, so you have to write down not mu s but mu k. Okay, and you know how to you know the magnitude of frictions. Force in this case is mu multiplied by n. Okay, and the last things in this problem is you have to know how to apply the second law from Newton. It's okay. That's everything. And the C part is from the chapter 1. You see that? We move to the next problems. Okay. So in this problem, you have to work on incline. Okay. So what is difference from these problems? The difference is in these problems, n here equal p, n here equal m, also the magnitude, n equal mg, okay, and it equal p in magnitude, okay. But when you work on incline, okay, the gravitational force is like this. Icon is p, okay, and you have to decompose it into two components. Icon is p1 and p2, okay, and the normal force in this case just equal in magnitude with p1, not p, okay. That is the difference. And here in the magnitude equal p1, okay. So the friction force, it can be static or kinetic, depend on if it's move or not, but friction force will be equal mu in general can be mu s or mu k multiplied by n, and in this case is just p1, not p here, okay. That is the difference when you have the object on a flat surface or on an inclined, Okay, it's a difference. You understand it? Keep in mind here is end. Okay, and the way we determine end will be different when the object on a flat surface or on inclined. Okay, so here let me draw it. I have an incline and it is 30 degrees. Here is the mass of the body. Okay, start from rest up the top. So here is a object. Okay, start from rest is mean v0 v0 is 0. Okay, and accelerates uniformly down, moving. Okay, moving here 2 meters in 1.5 seconds. 5 magnitude. So easy, right? 5 coefficients. Kinetic friction because it's moving. Okay, so it will be kinetic friction, not static friction. Okay. Okay, here you have to determine mu k. Here you have to determine Fk, kinetic friction. Okay. Okay. So because it's moved down, okay, move down to maybe this position. Okay. So it means it's moved down like this. So friction force should be like this. Okay. Icon is F. K because it's kinetics. Here is P. Okay, P. So we have decompose it into 2 components. Here, P1, P2, and here is the normal force. Okay, so someone can help me to solve this problem.
Can I do it?
Yeah, tell me your name and student code.
Quang Vinh,
Vinh.
BI11 103. Yes.
Okay.
So first we have to find the acceleration. We have the distance s equal to v0 t v0 times t plus
In fact, don't make the mistake between the distance s and x. Okay, here's equation of the position should be x.
yes.
Okay, and the general equation for it will be x0 plus v0 t plus 1/2 at square, right?
Yes.
But if the origin of the coordinate you call is here at the beginnings of the motion of the object, so x0 will be 0, 2, right?
And
Be careful when you x or s.
yes.
Okay, and
v0 also e0.
v0 because it's moved from the rest. Okay, so v to be 0, 2.
So we have acceleration a equal to 2x over t square.
Okay, they give you this information. Okay, the time during 1.5 seconds. Okay,
And equal to 2 multiplied with 2 over 1.5 square equal to 1.7 meter per second square.
the value I calculate here is 0.78 meter per second squared. Okay.
Yeah.
It's just from chapter 1. Okay. Here, the B part.
Now we choose the coordinate O, X, Y.
How about the positive direction of our X and the Y?
OX has direction of the moving direction of the object.
Also here OX and here OY, okay? Okay.
So we have the second Newton law. Fk plus F plus F
F, what is F?
is the maybe V0.
But what is F? Fk is friction force. You said plus F.
No, it's P. It's P.
P.
We don't have F. And plus N
Plus N.
equal to MA.
A. Okay.
So we consider the equation on OX, and we have
You
P.
project the equation on OX. Okay.
And minus Fk.
Minus
Fk
Fk because it's opposite to the OX. Okay.
plus P2.
Plus P2, you can write it down. P2.
And equal to M minus A. M to A.
Okay.
So Fk equal to P2 minus MA. So Fk equal, we have Fk equal to U multiple with mg.
Mu K
Mu
multiplied by
mg. Mg
really?
multiple with P.
No.
No. Multiple with N.
Just explained before the general equations for friction force equal mu multiplied by N. It's always N, normal force. Okay? And the normal force in this case is just equal
P1
P1 in magnitude. Mu K
P1
P1.
and P1 equal to P multiple with cos 30 degree.
M G cosine 30
30 degree.
Okay.
So
You should reply it into this, right?
yes, mu K
So you have mu K multiplied by mg for 30
equal
equal
to mj sine 30 degree equal to m a.
m a. Okay, so you have remove m. Okay, you know a, you just calculate it is the part a, right? You know g constant. Okay, you know cosine and sine of the 30 degrees, so you can know about mk. Okay.
Okay, equal to sine 30 degree.
Sine 30 degree minus a over cosine 30 degrees. Tell me the result, please.
Equal to approximately 1.825.
No, it's normally it's just how to say, smaller than one. How it can be larger than n? No, never. Calculate it again. Các bạn học ở đâu mà em lại lớn hơn một đấy?
Anh nhầm ạ.
Học vật lý là giá trị của nó có ý nghĩa nha.
Is equal to 1.2.
No.
0.2. 204.
No. The value I calculate here, someone can help me to check if you did it at home. 367. Do you have the same value with me? How about the others? Okay, check it because here's the results. Okay, so I have another ways. If you use the seconds law from Newton and you project each on a y, you can calculate directly the n. Okay, because you have what? P1 n minus P1 will be equal 0. Okay, so we have n equal P1, n equal mg and cosine theta. You can calculate it, right?
Yes.
Okay. When you have n, you have mu k here, and you can calculate. Sorry, t part. Because of limited time, so I have to go a little bit fast. Okay, so you can calculate fk. Okay, mu k here, you calculate it. You just need to calculate n. Okay, mg cosine theta. Okay, and the results here is 9.7 37 here. Okay. How about the last part? The speed of the block is so easy to write. Because they give you the distance s. Okay, you know about the acceleration here. Okay, you know about v0. Okay, so you easy to calculate vt. Okay, the d part, vt will be equal v0. You know it. Okay, and at. Okay, because t here, you know it. Okay, you know the time it takes to slide a distance of 2 meters here, or maybe you can use another way to calculate it. You know vt square minus v0 square equal to as. You know s. Okay, you know a. You know the initial velocity, so you can know the speed. Okay, after it's like a distance of 2 meters. Okay, whatever. And the result is
2.667.
667 meter. Never forget the unit. Okay. Oh my god. I need to finish in 2 minutes, right? Bao giờ cũng phải kết thúc cái lớp này nhỉ?
10 giờ 15 mới hết giờ.
Ôi dồi ôi, cô cứ tưởng 9 giờ 45 là cô tua như là gì nữa. Ô cô 10 giờ 15 à?
Vâng.
Okay, so sorry. Okay, cô lại nghĩ là 9 giờ 45. Okay. So any questions about this part? So keep in mind that I just remind you 5 minutes ago. Okay. The friction force will be equal mu multiplied by n. Okay, n here, the way you determine is very important. If the object is on an incline, n here is just be a part of gravitational force. It's equal P1. Okay, not P. It's okay. Keep in mind that n, not P. Okay. I think it's the only thing you need to remember about this. Okay, the part IE from chapter 1, the part D is also from chapter 1. So easy, okay? Only the part B and the part C is what you need to learn from these chapters related to the friction force, okay? The way you determine the direction is opposite to the ways objects move, okay? Objects move downward, it means the friction should be upward like this. Okay, it's the direction, and the magnitude is equal mu multiplied by n. Okay, if it's moving, the mu here should be mu k, kinetic friction. Okay, and if the object attracts, it should be mu s. Okay, mu k and mu s is different from each other. It's okay. So now we can move to the next problems where you have to understand both mu s and mu k. Okay. So in these problems we have two blocks, okay, with different mass, and they are stuck on a table with a heavy block on the top. Okay, so I call it M1, here EM2, okay, and the heavier block on the top, so M1 here, M1, and here is M2, okay. Wait a little bit. Okay, so heavy block on the top, so M1 is heavier, so it's on top, okay, here M2. Okay, coefficient of static frictions is 0.6 between two blocks. Okay, so here, wait a little bit. We have here interface between M1 and M2. Okay, so what does this mean? It means maybe we have the relative motion between M1 and M2 where we have to care about frictions. Okay, and they give you the static frictions between M1 and M2. So I will call mu 1 to S. Okay, static will be equal 0.6 and 0.3 between the bottom block and the table. Okay, so here we have another interface between M2 and the table. Okay, so I will call mu 2 TS. T is table. T stands for table. S is static. Will be equal 0.3. the horizontal force is slowly applied to the top block until one of the blocks move. And we don't know which blocks will move, okay? But we know that we have the horizontal force, I call it F here, acting on the top one. I call it F. Okay. The question is, where does slippage occur first? Between two blocks or between the M2 and the table. And you have to explain why. Okay. So you have M1 here, M2 here. Okay. They give you the static frictions between M1 and M2, the static frictions between M2 and the table. And we acting a force in this direction to the M1. The question is, what will slippage first? Okay, the M1 move on the surface of the M2, or both M1 and M2 move on the surface of the table. It's a question A. In the part B, they ask you about the values of the coefficient of static frictions between the M1 and the table. So that will change the answer from the part A. Okay, so to understand it, you have to know how to say when an object move on the surface of another one. Okay, so here, if I have an object, it's a table. Okay, and I have another object on it. I call it M. M here. Okay, so because we have the interface between M and the table, okay, it means maybe we will have the relative motions between them. It's when we have to care about the frictions. Okay, mu S and mu K. We care about mu S when the relative motion is 0. We have to care about the mu K, the kinetic motion, when the relative motions between them is not 0. Okay, so now we're acting a force on the mass. Okay, so at the beginning, the force is just so small. Okay, it's just so small. The object doesn't move, right? The object doesn't move. But Newton said that if the object doesn't move, it means the next force acting on it should be 0. So you have the force acting on this direction. So should we have another force acting on it in opposite directions? Okay, so in this case, F. Oh my God. F S. Okay, it is static frictions in opposite direction to the force F. Okay, and then we increase this force. Okay, it means the friction force here will be increased too, right? It right or not? Here question. You learn from Miss One, so answer my question. You increase the static force or not? The static friction or not? And why? and when the objects will start moving? Is the question. Các bạn có hiểu câu hỏi của cô không nhỉ? Sáng mai trả lời gì nhỉ? Ủa, nó mình đi đâu hết rồi? Các bạn có hiểu câu hỏi của cô không? Các bạn có đang hiểu bài toán đang nói về cái gì không? Các bạn có đang hiểu về bài toán đang nói về cái gì không? Không ai nói gì à? Các bạn ơi.
Đây cô, bọn em vẫn đây mà.
Okay. So when you increase this force, but the object doesn't move yet, it means you increase the static frictions. Okay, and when you increase to the value of mu s multiplied by n, okay, when the force you acting on the objects, it start get over this. Okay, start get over this value. Okay, and the object starts moving. You understand it? You understand it? So here is the limitations of the static frictions. Okay, here is the maximum value of static frictions. You understand? The maximum value of static friction. Okay, when the force you acting on the object larger than the maximum value of static frictions, the object start moving, and when it's moved, you don't have the static friction anymore. You have kinetic friction, and because the mu case is smaller than mu s. Okay, so you will see that, okay, now the force you're acting on it is even smaller than before, and you keep moving the objects. Okay, it doesn't stop. Okay, it's physics. Okay, so here to know where does slippage occur first, you have to calculate the maximum static friction here and the maximum static friction here, right? Because you only have one value of force acting on them. Okay, okay, so what happens if, answer my question, here you have the normal force. For example, you have the normal force because you know the mass. Okay, you know about the static friction, so you can calculate the maximum value of static friction at this position. Okay, I call it the F12S. Okay, 12S is static friction force between 1 and 2. And you can calculate the maximum values of static friction between M2 and M1 and the table. Okay, not M2, because M1 here acting a normal force on these interactions as well. Okay, not the normal vector from M2, but also from M1. Okay, so you can calculate the maximum value of static frictions at this position. Okay, what happens if this rather than this. What happened? It's a question. What happens if the maximum value of static friction at this position, I call each one, rather than the maximum value of static frictions at this surface, I call it 2, m rather than 2. It means we need a rather force to make it move, right? To make the m1 to make the relative motion between them is different from 0, right? Các bạn có hiểu cái này không nhỉ? Các bạn không phản ứng gì làm cho cô thấy băn khoăn, nhưng mà các bạn có đang hiểu cô nói gì nhé?
Cô cứ nói đi ạ, cô cứ nói.
Okay. So now, your job is you have to calculate them and compare them to each other to know, right? So someone can do it for me, please. Someone can do it for me, please. No one? Bài này lớp mình không ai làm được à? Okay. So I will do it myself. I will have the bigger sketch. Okay, I have here. M2. Here is M1. Okay, so first I have to determine the free body diagram. Okay. So on M2 first. So M2 you will have what? Or maybe M1 first, okay? M1 you will have here. I will change the color. The gravitational force acting on M1, okay? I call it P1. Okay, and because you have the interactions between M1 and M2, okay, so if you have the P1 like this, you have the reaction force or the normal force, and one is like this, opposite directions. Okay, and because the force acting on both objects have these directions. Okay, so you will have the friction force here. Okay, so I will call it F friction 1. Okay, it's okay. It's okay. So now to the M2. M2 itself will have the gravitational P2, but on top of P2 you have P1. So gravitational force acting on it will be P1 and 2 as well, right? And because of P1, 2, you have the, I will change the color. P1, 2. Okay, because of P1, 2, so we have here E and 1, 2. Okay, and because due to the force acting on this on the to the right directions. So at this surface you have as well the friction force in these directions. Okay, F2 or maybe 1 2 because it's due to both mass 1 and mass 2, right? Because here I use 1 2 for P and N, so friction here I use M2 as well, 1 1 2 as well. Okay, so now if you write down the equations, the second law, the second Newton law for the mass 1, mass M1, you will have what? The P1 plus N1, right? Okay, and plus F1. Okay, here is static frictions, the maximum static friction. It means we will care about the static frictions when the relative motion is 0. Okay, it means the object is at rest, so this will be 0. Okay, so if I call the directions here is positive to the right like this. Okay, if I project it on x directions, what do you have? You have F. Sorry, I forgot F. Plus F. Okay, I forgot F here. So if I project it on OX, I will have F because F is have the same direction with OX. Okay, we don't care about P1 and N1 because it's perpendicular to OX. Okay, minus F1 because it's opposite will be equal 0. Okay, so you have F here will be equal mu 0 S1. Okay, here mu 0 S1 is the static frictions between M1 and M2 multiplied by the normal force here is just N1. Okay, so M1G. It's okay? It's okay? Here
Yes.
is okay. The second law for the M1. Okay. And for the rest one here, you have to care both about M1 and M2 because they are stuck to each other. Okay. Color. So you have for M1 plus M2. What do you have? P12, okay, plus N12 plus F12, okay, and never forget F here. Because due to F, you have static friction here, okay? And it will be 0 because we are caring about static friction. This means both objects are at rest, okay? And if you project equations on OX, you have the same F will be equal F12, okay, is equal mu S m2 here, okay, multiply by the normal force here, and m12 will be equal P12, right? Will be m1 plus m2 multiplied by G, right? Right?
Yes.
Okay. So now you know m1, you know G, you know ms1. Okay. Here you know m1, m2, G, and ms12. Okay. I think here I will change a little bit here. I call, oh, you don't need to change. Okay. So you will calculate the maximum static frictions force here. Okay. And you come to the value is will be equal. Let me find. Can you calculate it and tell me the value, please? 0.6 multiplied by 45 multiplied by 9.8 equal what? $264.6 newtons. Okay, and here 0.2 multiplied by 45 plus 32.5 multiplied 9.8 equal 200 and 30 newtons. Okay, so when you look at this, it's 60, right? When you look at it, you see that okay, you need more force, okay, more force to get over the static force between two blocks. Okay, here is the friction between two blocks. Okay, the static force here is not much higher, is higher than static force here. Okay, what does this mean? It means the force you apply should be higher, okay, to get over this static force, to make it move. Okay, so what is the conclusion? What does this mean? It means we need, we need more force. Okay, you see, higher than this, more force, okay, to get over the static force between, static force should be between something, between two blocks, then between the second blocks and the table. Okay. For example, here the force at the beginning is to be 10 newtons, nothing move. 100 newton, nothing move. Okay. 200 newtons, Nothing move, but 202 Newton larger than this. So both objects will move together. Both objects will move together. And then when the force you apply to is 270 newtons, larger than this as well. So both objects will move, and the object 1 will move relative to the object 2 as well. You understand it? Cái bài này cực kỳ quan trọng nha, các bạn phải hiểu nha. Ok. Ở đây các bạn có hai vật M1 và M2. Ok chưa? Các bạn tác dụng một lực ép lên nó. Câu hỏi là cả hai cái khối này sẽ di chuyển so với cái bàn, hay là thằng M1 sẽ di chuyển so với thằng M2 trước? Chuyện gì xảy ra? Di chuyển ở đây hay là di chuyển ở phía bên dưới này trước? Ok chưa? Để trả lời cho câu hỏi đấy thì chúng ta phải làm sao? Tính được cái nó gọi là ma sát nghỉ, static friction, tại vị trí này, đúng không? Giữa hai cái lớp tiếp giáp này, và gì? Ma sát nghỉ giữa cái M2 và cái bàn. Ok chưa? Để tính được cái ma sát nghỉ đó thì chúng ta chỉ cần áp dụng cái định luật 2 Newton thôi, đúng không? Ma sát nghỉ tức là chúng nó đang đứng yên thì nó sẽ phải bằng không hết. Ok chưa? Các bạn sẽ tìm ra được cái lực ép này cần để làm sao vượt qua được cái ma sát nghỉ đấy là bao nhiêu, đúng chưa? Bởi vì cái ma sát nghỉ chỉ cần lớn hơn cái ma sát nghỉ đấy làm sao nó sẽ bắt đầu di chuyển. Thế thì mình xét ở cái đoạn mà ngay trước khi nó di chuyển, cái đoạn mà cái lực tác dụng nó bằng đúng cái lực ma sát nghỉ lớn nhất ạ, đúng không? Thì mình áp dụng cái định luật 2 Newton thôi. Ok chưa? Thì mình thấy là gì? Cái ma sát nghỉ giữa hai cái thằng block ấy nó là 264,6 Newton. Nhưng mà cái thằng ma sát nghỉ mà ở cái thằng M2 với cả cái bàn này nó chỉ có 201 Newton thôi. Ok chưa? Thế nếu mà bây giờ mình tác dụng một cái lực ép nha, ví dụ lực ép bây giờ là 10 Newton chẳng hạn, chẳng thằng nào di chuyển cả, bởi vì nó đều quá nhỏ so với cả gì? Hai cái lực ma sát nghỉ ở đây. Ok chưa? Nếu là 200 Newton chẳng hạn cũng không thằng nào di chuyển nha, bởi vì nó vẫn nhỏ hơn. Nhưng nếu là 202 Newton chẳng hạn, ok chưa? Là cả hai cái khối này nó đang dính với nhau và nó đang cùng di chuyển so với cái bàn. Ok chưa? M1 và M2 vẫn dính nguyên so với nhau nhá. M1 và M2 nhá, vẫn đang dính nguyên so với nhau. Ok chưa? Nó đang không tách rời khỏi nhau đâu. Và hai thằng đó đều đang di chuyển. Nếu mà cái lực các bạn tác dụng mà lớn hơn được cái lực ma sát nghỉ giữa hai thằng là 264,6 Newton đấy, ví dụ mình lấy ví dụ là 270 Newton chẳng hạn, được chưa? Thì hai thằng này nó đang di chuyển so với bàn, và lúc này thằng M1 nó cũng di chuyển trên bề mặt của thằng M2 luôn. Các bạn hiểu ý nghĩa của cái lực ma sát nghỉ chưa? Các bạn hiểu chưa? Hiểu rồi nha. Ok. In the B part, they ask what value of coefficients of static friction between the bottom block and the table would change the answer in the part A. So in the part A, okay, in the part A, the slippage between the bottom blocks and the table occurs first, đúng không? Trong cái phần A ấy, thì cái việc trượt xảy ra giữa cái thằng phía bên dưới này và cái bàn nó sẽ xảy ra trước so với việc mà thằng M1 bị trượt trên thằng M2. Bây giờ câu hỏi là cái hệ số ma sát nghỉ giữa cái thằng M2 và cái bàn này nó sẽ phải như thế nào để cho thằng M1 nó sẽ làm sao trượt trên thằng M2 trước. Ok chưa? Cái câu hỏi cái này rất đơn giản thôi. Khi nào các bạn có cái đấy nhỉ? Ký. When do you have it? M1 mặt trượt trên thằng M2 trước thì cái làm sao? Cái thằng lực đây nó liên quan đến lực ma sát nghỉ nó sẽ phải làm sao? Nhỏ hơn thằng này, đúng không? Để cái lực tác dụng làm sao? Nó sẽ thắng được cái thằng ma sát nghỉ của thằng M1 và M2 trước, đúng không? Thế thì trong câu B các bạn chỉ cần làm sao? Mu S1 M1G should be smaller mu S12 M1 plus M2 multiply G. Right? So remove G. So you have mu S M 12 should be larger than mu S1 M1 over M1 plus M2. Có đúng không? Các bạn có hiểu cái phần này nhỉ? And it will be equal 0.394. Ok? Các bạn có hiểu cái phần này không? Để cho M1 mà trượt trên M2 trước, nó xảy ra trước, thì cái gì? Lực ma sát nhỉ ở đây nó sẽ phải làm sao? Nhỏ hơn là lực ma sát nhỉ của cái thằng M2 so với bàn, đúng không? Mà mình tính được cái lực ma sát nhỉ ở đây rồi, đúng không? Nó sẽ phải nhỏ hơn. Ok chưa? Các bạn tìm ra cái coefficient of static frictions giữa cái thằng M2 này và bàn, nó sẽ phải lớn hơn 0,394. Ok chưa? Cho là cô không đủ thời gian chữa phần cuối rồi. Ok chưa? Thì như cái tình trạng này xảy ra chung với các lớp á. It's okay. Các bạn ơi. Vậy thì các bạn chấm.
Cô có thể provide cho bọn em cái bài chữa được không? Tại vì đây cũng là buổi cuối rồi, nó cũng sắp thi rồi.
Bài chữa gì nhỉ? Không hiểu. Bài này
Solution cho tất cả các cái answer, các cái problem.
Solution thì theo cô biết là cô Vân chỉ muốn release cái kết quả thôi. Bởi vì thì nhá, cô Vân cũng sẽ phải gửi cho cô tất cả các cái đáp án ấy, nhưng mà các bạn sẽ thấy là sẽ không có cái solution nào đâu các bạn ạ. Ví dụ như cô chẳng hạn, cô dạy các bạn nha, là cô cũng sẽ phải tự làm từ này. Chắc các bạn có đang nhìn cái cô share không? Nên là chúng ta sẽ không có cái solution cụ thể nào nếu chúng ta không đi học đâu. Bởi vì ngay bản thân các cô mà đi dạy bài tập ấy, là các cô cũng sẽ phải tự làm hết á. Đây này, ví dụ cô cũng dựa trên bài của cô Vân cũng chỉ cho solution, kết quả A, kết quả B bao nhiêu, các bạn thấy không? Bài nào cũng thế thôi, không có cái gì hơn các bạn đâu. Ok chưa? Nên là cô phải làm thì các bạn cũng sẽ phải làm thôi nhá. Và bằng cách là các bạn follow các cái bài giảng của cô trên lớp, thế mới cần đến các cô chứ, đúng không? Nếu không mình đến lớp làm gì? Có solution rồi đến lớp làm gì? Ok chưa? Các bạn hiểu không? Theo mình biết là cô Ngân hoặc là cô Ngọc, cô Bích Ngọc sẽ gửi cái đáp án, chỉ có đáp án thôi các bạn nhé, không có solution cụ thể cho tất cả các bài đâu. Ok chưa? Các bạn có bài nào khó các bạn muốn hỏi, các bạn có thể mail hỏi cô, không vấn đề gì, cô sẽ cố gắng trả lời, nhưng mà cố gắng mà gom lại với nhau mà hỏi thì đỡ mất thời gian hơn cho cô. Ok chưa? Các bạn đừng quên gửi cái bài tập cho cô để cô chấm đầu điểm bài tập cho các bạn nha.
Bài tập từ bài nào đến bài nào của cô?
Những cái bài hôm nay cô chữa trên lớp. Ok chưa?
Vâng.
Thêm thì càng tốt. Bye bye các bạn nha, bởi vì các bạn phải có lớp học khác rồi nên cô sẽ không thể níu chân các bạn nữa được, đúng không?
Có cái bài vừa rồi thì cô có thể tạo solution để gửi cho em không? Cái bài 21 ạ.
Cô tạo solution gửi cho em không, cô chữa trên lớp thôi, cô không tạo solution được.
Vâng.
Chịu khó viết ở trên này thôi. Có gì không hiểu các bạn sẽ có thể hỏi thôi. Các bạn chỉ cần nhớ trong đầu đó là cái lực ma sát của các bạn phải nhớ nhân với cả cái phản lực nha. Ok chưa? Phải xác định đúng phản lực. Ví dụ như là cái N12 ở đây này, chứ không phải là chỉ có mỗi cái vật M2 đâu mà phải có cả M1 nữa. Đây là phải là M1 cộng M2 nhưng rồi. Cái này cũng sẽ mà luyện tập mấy bài là quen mà. Ok chưa?
Dạ vâng.
Ok.
Chào cô.
Ok, bye bye các bạn nha.